Welcome to Kuma English Listening Hub. Today we're going to talk about something you probably use this week, maybe even today, but rarely think about: elevators. Elevators feel simple. The doors open, you step in, you press a button, and a few seconds later you arrive. But behind that easy experience, there is a surprisingly complex system of engineering, software, and safety planning. In this episode, we'll explore how modern elevators think, how they decide where to go, and why they are designed to be one of the safest machines in daily life. Let's start with a basic question. What is an elevator technically? An elevator is a moving room that travels vertically inside a building. It carries people or goods between floors using a motor, cables, and a control system. Older elevators used very direct mechanics, but modern ones are like small computers that manage traffic, energy use, and safety checks. Most elevators you see in offices or apartment buildings are traction elevators. This means they use steel ropes, sometimes called cables, that run over a pulley at the top of the elevator shaft. The pulley is connected to an electric motor. On the other end of the ropes, there is a counterweight. This counterweight is almost as heavy as the elevator cabin when it is about half full. The counterweight is important because it makes the system efficient. Instead of lifting the full weight of the cabin, the motor mainly needs to overcome the difference between the cabin and the counterweight. If the cabin is heavier, it goes down slowly, unless the motor pulls it up. If the counterweight is heavier, the cabin is pulled upward unless the motor controls it. This balance reduces energy use and makes the ride smoother. Now, what happens when you press a button? Many learners imagine the button is directly connected to the motor like a simple switch. But in modern elevators, the button is more like sending a request to a brain. The elevator controller is a computer that collects information: which floors have calls, where each elevator car is, which direction it is moving, and how many doors have recently opened. In a building with one elevator, the decision is easy. If someone calls the elevator, it goes to that floor. But in a building with multiple elevators, decisions become more complicated. The system wants to reduce waiting time and avoid wasted trips. So it uses algorithms, which are sets of rules that help it choose the best action. For example, imagine 3 elevators in a tall building during the morning rush. Most people are entering on the ground floor and going up. The system may park one elevator near the ground floor because it predicts more people will arrive. Another elevator might serve only higher floors. Some systems even use a feature called destination control. Destination control changes how you request an elevator. Instead of entering the cabin first and then choosing a floor, you choose your destination on a screen in the lobby. The system groups people going to similar floors into the same elevator. This reduces stops, saves time, and lowers energy use. It can feel strange at first, because you might not get the closest elevator. But overall, the building works more efficiently. Let's talk about speed. Some elevators move slowly, like in small apartment buildings. Others are incredibly fast, especially in skyscrapers. High-speed elevators must deal with problems that slower ones don't have. One issue is air pressure. When an elevator moves quickly in a tall shaft, it pushes air, and that can cause uncomfortable pressure changes in your ears, similar to what you feel on an airplane. To reduce this effect, some buildings use pressure control systems and special ventilation designs. The cabins may also be built to reduce noise and vibration, because at high speeds, even a small shake can feel dramatic. Another interesting part is how elevators know where they are. They need to stop precisely so the floor of the cabin matches the floor of the building. If it stops too high or too low, it can cause people to trip. Elevators use sensors to measure position and speed. These can include magnetic sensors, encoders attached to the motor, and switches along the shaft. When an elevator approaches a floor, the controller slows it down smoothly. Modern elevators are designed to feel comfortable. You may notice that the cabin starts slowly, speeds up, and then slows down again. That is not accidental. A comfortable ride is part of the design, and it also reduces stress on mechanical parts. Now, let's move to a big question that many people secretly worry about: safety. Movies often show elevators falling or cables snapping. In real life, modern elevators have many layers of safety. First, the cables. Traction elevators do not rely on one cable. They use multiple steel ropes. Each rope is strong enough to carry a large load, and together they provide a big safety margin. The ropes are also inspected and replaced on a schedule. Second, the brake system. Elevators have brakes that can hold the cabin in place. When the elevator is stopped, the brakes are engaged. When it moves, the system releases the brakes under controlled conditions. Third, the famous safety device, the governor and safety gear. If an elevator starts moving too fast, a speed governor can detect overspeed. Then it triggers safety gear that grips the rails in the shaft and stops the cabin. This system is designed so the elevator cannot simply fall freely. You may ask, what about power cuts? If the electricity goes out, most modern elevators have emergency systems. Many will move to the nearest floor and open the doors. Some buildings have backup generators that keep elevators running, especially in hospitals or high-rise buildings where stairs are not practical for everyone. Another safety feature is the door system. Elevator doors are designed not to close on people. There are infrared sensors or light curtains that detect when something is in the doorway. If the sensor is blocked, the doors reopen. This prevents injuries and also prevents damage to the doors. Let's also talk about capacity. Inside an elevator, you might see a sign with maximum weight and maximum number of passengers. That is not just a suggestion. The elevator has load sensors that can detect if it is overloaded. If the weight is too high, the elevator may refuse to move and will sound an alarm or display a message. Now, here's something you might not think about. Elevators are not only machines, they are part of a building's traffic system. In a busy building, the elevator plan affects daily life. For example, if the elevators are too slow or too few, people waste time and feel frustrated. In offices, this can even affect work schedules, because groups may arrive late to meetings. Engineers sometimes study elevator traffic the way city planners study road traffic. They look at peaks, mornings, lunch breaks, and evenings. They calculate something called handling capacity, which is how many people can be moved in a certain time. They also consider waiting time, which is how long people stand in the lobby. To improve traffic, buildings may use zoning. One group of elevators serves lower floors, another serves middle floors, and another serves higher floors. Some buildings also use sky lobbies, which are like transfer floors. You take an express elevator to a sky lobby, then switch to a local elevator to reach your final floor. This reduces the number of stops and allows buildings to be taller without needing too many elevator shafts. Elevator shafts take up valuable space. In very tall buildings, if you built enough elevators to serve every floor directly, the building would have too many shafts and not enough office or living space. That's why designers use express systems and smart scheduling. What about energy use? Elevators consume electricity, but modern designs can reduce waste. For example, regenerative drives can capture energy when the elevator slows down or when a heavy cabin goes down. Instead of turning that energy into heat, the system can send it back into the building's electrical network. In a busy building, this can save a noticeable amount of energy. Maintenance is another hidden part of elevator life. Elevators are checked regularly. Technicians inspect cables, brakes, doors, and control systems. Many elevators are now connected to remote monitoring. This means the elevator can send data about errors, unusual vibrations, or door problems to a service center. The goal is to fix issues before they become serious. This is called predictive maintenance. Now let's look at the human side. Elevator etiquette is different across cultures. In some places, people stand quietly and avoid eye contact. In others, short conversations are normal. In many cities, there is an unspoken rule. Stand on one side to let people walk past on the other side, especially on escalators, but sometimes people apply similar habits in elevators. There is also accessibility. Elevators are essential for people with mobility challenges, parents with strollers, and travelers with luggage. That's why buttons often include Braille and why the cabin may announce floors with audio. Some elevators also have longer door open times or special modes for service use. You might be wondering, what is the future of elevators? Engineers are experimenting with new ideas. Some companies are developing rope free elevator systems that can move both vertically and horizontally using magnetic technology. If this becomes common, it could change how buildings are designed. Imagine elevator cabins that travel like trains inside a building, moving around corners. Even without such dramatic changes, elevator technology is improving in smaller ways. Better algorithms, smoother rides, quieter motors, and stronger cybersecurity. Yes, cybersecurity. Because modern elevators are connected systems, engineers must protect them from hacking and software errors. That's a new challenge compared to older, purely mechanical elevators. So, the next time you step into an elevator, you can remember that it's more than a box on cables. It's a carefully balanced machine, guided by sensors and software, designed with multiple safety layers, and planned as part of the building's living system. Before we finish, here's a small listening challenge. Think about these questions. In your daily life, where do you use elevators most often? Do you prefer stairs, when possible? And have you ever been in a building with destination control, where you choose your floor before entering? Thanks for listening to Kuma English Listening Hub. If you want to practice more, listen again and try to notice how we used cause and effect language, like because, so, and that's why. See you in the next episode.